Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X published on January 28, 2026, about 5 days ago. It presents a striking experimental finding that developers using AI assistants to learn a new coding library scored 17% lower on skill evaluations compared to those who worked without it. The paper is titled, How AI Impacts Skill Formation. And as we'll see later, the breakdown of user interaction patterns offers some really critical insights for maintaining human expertise in the age of automation. Figure 1 visualizes these core results, splitting the data into overall metrics and specific user behaviors. On the left, the task time chart reveals a surprise. Using AI, shown in blue, did not actually make participants significantly faster than those working manually in orange. However, the quiz score chart next to it confirms the learning cost, with the manual group scoring significantly higher. Then, the right panel maps out distinct interaction styles. It shows that active strategies like generation, then comprehension, preserve learning, while passive ones like AI delegation sit at the bottom with much lower scores. Figure 2 illustrates the conceptual framework driving this study. The top path represents the traditional workflow without AI, where a novice worker must pass through a distinct learning phase to complete the task. In contrast, the bottom path shows the AI-assisted route. This acts as a direct shortcut, indicated by the dashed line, allowing the worker to bypass the learning stage entirely. This visualizes the core concern that immediate productivity might skip the cognitive friction needed for mastery. To ensure the results weren't skewed by prior skill, Table 1 breaks down the demographics for the 52 participants. It compares the treatment and control groups across metrics like coding experience and Python frequency. Crucially, the cohorts are well matched, with most developers holding over 7 years of experience. The difference column on the right confirms this balance with minimal variation, which means any performance gaps found later can be attributed to the AI tool itself rather than pre-existing ability. With the participant pool established, Figure 6 presents the core experimental results. The left panel plots task completion time, where we see that the AI group in blue was slightly faster on average, but the overlap with the orange manual group shows this difference wasn't statistically significant. However, the middle panel reveals a major gap in skill formation. The manual group scored about 15 percentage points higher on the quiz than the AI users. Finally, the rightmost chart quantifies this, confirming a significant impact on learning outcomes despite the lack of meaningful productivity gains. So where exactly did the learning falter? Figure 8 breaks down the quiz performance into specific sub-areas to pinpoint the deficits. Across every category, the manual group in orange consistently outperforms the AI group in blue, but the most telling result appears in the debugging column. Here, the performance gap is massive, dropping from about 60% for manual users to under 40% for the AI cohort, which suggests that skipping the struggle of fixing errors prevents users from developing critical diagnostic skills. While the previous figure showed the overall deficit, Figure 11 explains the mechanism by mapping 6 specific interaction personas against their quiz scores. The vertical axis separates these behaviors into 2 distinct clusters. High performers, found at the top, use strategies like generation then comprehension, where they actively verified AI outputs, achieving scores up to 86%. Conversely, the bottom cluster reveals the cost of passivity. The AI delegation group, for instance, saved time but failed to learn. Most strikingly, the iterative AI debugging group on the far right spent the most time working but ended up with the lowest score of all, demonstrating that offloading the thinking process is detrimental even when it takes longer. Moving to the mechanics of how the code is actually written, Figure 13 tests whether manually typing out AI-generated code aids memory better than just pasting it. On the left, the total time chart confirms that the code pasting group finished the fastest, while those who manually copied the AI output took nearly as long as the control group. However, the quiz score chart on the right reveals that this extra effort was wasted. The scores for manual copiers were just as low as the passers, proving that mechanical retyping without mental engagement does not prevent skill loss. Wrapping up, 2 takeaways stand out. AI-enhanced productivity is not a shortcut to competence, and passive reliance on these tools can actively erode the skills needed to supervise them. The broader implication is clear. To maintain human expertise, we must design workflows that prioritize cognitive engagement over simple speed. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.